Hey everyone, welcome back to the channel. In today's video, we are going to divide into some of the basic objects in Kubernetes that are crucial for deploying and managing applications at scale. We will talk about the pods, deployment services, config maps and secrets. By the end of this video, you will have a clear understanding of this fundamental building block. So let's get started. Before we jump into the objects themselves, let's quickly review what Kubernetes is. A Kubernetes is an open source platform used to automate the deployment, scaling, and management of containerized applications. It's like a manager that helps running your app container and make sure they are always up and running the way you want them, and it uses object to do all this work. So let's look at these objects one by one. First we have pods. A pod is the smallest and simplest Kubernetes object. You can think of it as a wrapper around one or more containers that run together on the same host. A pod is the fundamental unit of deployment in the Kubernetes. All the containers in a pod share the same network namespace, meaning they can communicate with each other using localhost. Typically, you will see pod running a single container, but you can also run multiple containers in a single pod when they need to share resources like storage or networking. Example, a web server running in a single container or a multiple container sharing a common storage volume. Here is the diagram of the pod, which contains container that will run under the pod, and pod is under the node. Here an example of a single pod definition in YAML. As you can see, we specify the containers inside the pod along with the image to use, in this case an Nginx container. Next, let's talk about deployments. A deployment is a higher level abstraction in Kubernetes that manages a set of pods. It's what you use to ensure that a specific number of pods are running and always in the desired state. A deployment helps with scaling, meaning you can increase or decrease the number of pods running based on demand. It also makes rolling update easily. If you want to update your app, the deployment handle creating a new pods with update version and safely removing add-ons. This is the visual representation of multiple pods and deployment managing them. In pod, we have containers, and multiple pods are managed by deployment. We can see in the YAMLs file. For example, here deployment definition in YAML, where we are creating 3 replicas of Nginx pod. This ensures that Kubernetes will always keep 3 pods running. Now let's move on to services. In Kubernetes, pods are invariable, meaning they can be created and destroyed frequently. So how do we constantly access them? That's where service comes in. A service provides a stable endpoint for accessing a set of pods. It can load balance traffic across pods, making sure that the right pod gets the right traffic. Service can be exposed internally within the cluster or externally, depend upon the type. Example, Here an example where we define a service. Expose our Nginx pod on the port 80 and we are using the default cluster IP type to make it available only within the cluster. Let's talk about config maps. An application grow, they often require configuration setting like environment variables or configuration file. Rather than hard coding this setting into your application, you can use config maps to store and manage them externally. With config map, you can separate the application code from its configuration, which makes your application more portable and flexible. You can also update the config map without needing to change the application itself. In config map, value stores in the form of key and value. Here in an example where we define a config map with two key and value pairs, config 1 and config 2. The pod can access this config map as environment variable or as a file. Finally, let's talk about secrets. Just like config map, secrets store configuration data, but the difference is secrets are specifically designed to store sensitive information like password, API, token or private keys. While configuration map store plain text data, secrets store encoded data. Though keep in mind it's not encrypted by default. So you should use encryption at rest for the sensitive data. Kubernetes make it easy to inject these secrets into your pod as environment variable or monitor file. Here's example of secret definition in YAML where you are storing DB username and password. The value are base 64 encoded. They can easily be accessed by the pod. Alright, to quick recap. Pods are the smallest unit in Kubernetes where your application container runs. Deployment manages the lifecycle of pods including scaling and updates. Services provide stable access to pod handling DB and routing. Config map allows you to manage non-sensitive configuration outside your app. Secrets store sensitive data securely. That's all for today. If you found this video helpful, make sure to hit that like button, subscribe for more Kubernetes tutorial and leave any question you have in the comment below. Thanks for watching. I will see you in the next video.